All right, so we're going to take a look at an example problem of series circuits now that we have all the equations. So let's say we've got a circuit problem, series circuit, two resistors connected to a 12-volt battery. Two resistors have resistance values of 24 ohms and 36 ohms, and we're asked to solve everything. Now, if you look at the presentation already, I've got all the solutions with steps laid out in kind of like a color order, but I'm going to show you how to do this in slower steps. This slide serves to see all the numbers plugged in, but I'm going to take you through this problem step by step as if you were doing it from scratch. You didn't have anything to look at. So here it is again, 12-volt battery, resistors of 24 ohms, 36 ohms in series, and we're asked to solve everything. All right, so of course, the first thing you want to do is set up a chart. I've already got one here, VIR column. I only need 3 rows, resistor 1, resistor 2, and the total. Okay, so obviously the first thing you want to do is fill in your givens. So we have our resistance values of 24 and 36 ohms. I'll make the 24 ohms resistor 1 and the 36 resistor 2. So we're going to fill that in here and here. And then we were also told we had a 24-volt battery. That's the total voltage. Total voltage comes from the battery. So I filled that in down here. So this is all the information we have given, total voltage and each individual resistor value. You say, okay, well, how am I going to do this if I don't have, the simulation with the ammeter and voltmeter start taking readings like you did in your simulation lab? Well, that's where the equations come in. I'll scroll down a little bit and I'll show you those equations again. The equations I showed you first are really column equations for these charts. In fact, I'm going to scroll down all the way so we can't even see the picture anymore. We don't need it. The chart will have everything. The junction rule says that at a junction of a wire, current will split one way and another. Well, there are no junctions in a series circuit. Every electron passes through every component of the circuit, and charge isn't used up. It's just carried through. So the value of current is the same everywhere in the circuit. So the current coming out of the battery is the same as the current going through resistor number 1, which is the same as the current going through resistor 2, and then back to the battery. So I'm actually going to modify this equation, chop off 3 and 4. This is just saying, if there's more, then all the currents are equal. But we only have 2 resistors, so I really only have numbers 1 and 2 for the subscripts. Okay, so this is our modified equations for just this particular series circuit where there's only 2 resistors. Okay, so that means if we solve the current anywhere, it's the same everywhere. Well, we don't have any current values yet, so we'll keep that on hold. Second equation says that our total voltage from the battery is equal to the 2 voltages necessary to pass through each resistor. All right, well, we don't know what they are yet, but we know that they total to be 12. And then the last equation, total resistance is the all resistors combined. Well, that we can do. I'm actually going to color in all these columns so they match the colors of my equation, just to make it even more obvious what's going on. So the R equations, the I equations, make them green. And the V equations. All right. So total VRs, 24 and 36, add them together. If you can't do 24 plus 36 in your head, don't worry about that, but I'll give it to you now. It's 60. Grab a calculator and try that out for yourself. You can trust me on that one. By the way, I'm always going to make these problems so the numbers aren't completely wild. No weird decimals, that kind of thing. All right, so we've got our total resistance now. At this point, we can't use these column equations anymore. We still need more information. We have nothing about the I, nothing about what these 2 V values are through resistor 1 and 2 to equal to 12. Well, that's where the row equations come in. That's Ohm's law. Here's Ohm's law. V equals IR across any row. And they can modify that for I equals V over R or R equals V over I. You took a look at this at the end of last week. Well, so row equations or Ohm's law pretty much says if you have 2 out of 3 of the 3 values in any row, you can solve for the third one with one version of Ohm's law. So right now, the bottom row is the one we're looking at. We have voltage and resistance, V and R. So we can solve for I, the current. We'll use the middle equation here. 12 is our voltage, 60 is our resistance, 12 over 60. Well, that's 1 over 5 or 0.2. And again, current is measured in amps, so I'll put 0.2 amps in here. All right, well, so far we've got a total current of 0.2 amps, but that's this. This is 0.2. Well, if that's the case, the current going through resistor 1 and the current going through resistor 2 is also 0.2 amps because of the green equation. All currents are the same in a series circuit. And now we say, hey, 2 out of 3 in the top 2 rows now go back to Ohm's law. Current and resistance multiplied together equals voltage. So we'll take a look at the first row, 0.2 times 24. That's 4.8 volts. And then 0.2 times 36 for the I times R equals V over here. 0.2 36 is 7.2. And again, that's volts. All right, everything's solved. You can even check. We never used this blue equation. We knew the total voltage was 12 all along, but according to this equation, the two voltages needed to go through resistor 1 and resistor 2 added together should equal the 12 voltage we get back in the battery. 4.8 and 7.2, that does equal 12. So it's kind of a way to check to make sure you did everything correctly. If if you happen to have an equation you never touched, if it works, you must have solved everything correctly along the way. Hopefully this stepwise version helps. Again, you can go back to the slide to see the individual values. I just kind of spoke them, but you can see how everything works out here if you want to review. Hopefully you can handle the problems I left you. Just leave me a question in that document if you have any doubts.